Welcome back again, guys. Figure 3-2, page 228 from chapter 7 is, this figure gives a lot of headache, for some students. So, and this is what I've basically done. So for the first dimensional analysis that they've done here, I fixed triangle 1. And for the second one over here, which has Avogadro's number, I fixed triangle 2. Okay, so let's discuss triangle 2. So as you can see here, in this triangle, I talk about Avogadro's number, which is 6.022 times 10 to the 23. And then the second element is number of atoms, number of molecules, or number of particles. So the question that you're going to get on your SAT test will include one of these. It'll ask you to find the number of atoms, molecules, or particles. And then the third element is moles. Okay, so again, this is triangle 2. And a typical question that you will be, for instance, given the number of moles of a compound, and then they want you to find the number of atoms or particles or molecules. If it's a compound, of course, they're going to ask for the number of molecules, or just say particles. If it's an atom or an element, they're going to just say find the number of atoms. And Avogadro's number, of course, is given to you in the test. I mean, it's given in on the first page right after the periodic table, but just in case, I always advise my students to memorize it. And it's really not a hard number to memorize. It's just 6.022 10 to the power 23. Now, of course, I'm not just discussing these, the topics in McDougal as, just for, taking chemistry or understanding chemistry. I always give you advice on how these questions come in your subject test. So everyone knows that a calculator is not allowed. So basically, the number that you're getting here, so the College Board always puts the questions that make easy, straightforward calculations. So for instance, if you're trying to find the number of atoms or particles in general, of course, these two have to be multiplied by each other. So remember that there's always multiplication here, and this line over here means division. So in your SAT test, you're always going to get easy numbers. So if you're multiplying, I mean, they're going to give you 2 moles, 3 moles, 4 moles. And then the answer is going to be just a rough estimate. So let's say if it's 4, the answer is going to be 24 times 10 to the 23. Okay. If this requires division, like if the question is asking you for moles, and you need to divide the number of particles given by Avogadro's number, usually they give you the number of atoms or molecules that they give you is usually 2 or 3 or 6. So it's multiples of 6 so that the division process will be easy. So it's easy math. Now, as I always tell you, in your SAT subject test, they're always testing you. In every question, they're only testing you for one skill. Okay, they only want to test you in one skill. Keep that in mind. And actually, chemistry is one of those subject tests that really pay off if you pay attention to every skill and you master it. Okay, moving on. Now there's question 4, page 232 from formative assessment. So basically, this question, they give you 100 milligrams of aspirin, and which is C9H8O4, and then the unknown is the number of molecules. They're asking you for the number of molecules. Okay, so step one. Now, as you can see in both triangles, here you have moles, here you have Avogadro's number. Now remember that Avogadro's number, the unit the unit that it carries is number of particles per mole. So the unit of Avogadro, I'm going to say particles just in general because just to generalize it, because if you have atoms, then you're going to refer to it as atoms. If you have molecules, then it's molecules. So I'm going to say here it's number of particles per mole. So this is the unit, okay? This is the unit of it. And that's going to help you a lot when you do your dimensional analysis or you're converting, okay, when you're converting. Okay, so as you can see, also from the first triangle, the units are gram and mole. So there's no room for milligrams when we're doing stoichiometric calculations. So basically, and it's obvious, first step, convert milligrams to grams. Now, we know that 1 gram is 1,000 milligrams. So if I'm converting my 100 milligrams that are given here, oops, my camera, okay. If I'm converting that, we are going to divide by 1,000, and that's going to be 0.1 grams. Okay, so guys, this rarely happens in your SAT test. They're going to give you the mass in grams without the need of converting. And if they're going to ask you about converting, believe me, there's going to be a separate question, and that is one of the recent common questions in SAT subject test, chemistry. Yes, they're asking you how to convert. They're asking you about units. This is a new question that we've been seeing in our tests. As you know, I'm a proctor. I proctor some of these tests. So I can, I watch students solve, and I can, I watch them solve these questions. That's why I have an idea about what they get. Okay, let's move on to here. Let me just give a small tip because, there's personal differences between students. I always teach students when they convert. So if you're converting, now this is the big unit, this is a bigger unit, and this is the smaller unit. So if you're converting from big to small, okay, from big to small, then you need to multiply by the conversion factor. And if you're converting from small to big, then you need to divide, okay? So this is the only tip that you need to know when you're converting units. Okay, step two is finding the molar mass, okay? Now, as you can see here, we're asking for number of molecules. Okay, so you're gonna go ahead and say, okay, I'm gonna work on triangle 2. So this is what I need. And I have Avogadro's number. Okay, good. So I've got these two. Sorry, this is what I need to find. So these two have to be known. Avogadro's number is known. Moles is not given. But how do I find moles? From the mass that is given and link that to the second triangle. Okay, so this is one of those questions where you need to use both triangles. So over here, I have mass, I have molar mass, I find moles. After I find my moles, I go back and plug them in here, and then I just divide, and then I multiply Avogadro's number by moles, and then I get number of molecules. So this is my plan. Okay, so step 2 is finding molar mass, remember? Because I need to plug it in here, okay? I have mass, and then I will be having very, very soon my molar mass. Applying that, now look at your compound here. You have 9 carbons and 8 hydrogens, and you have 4 oxygens, okay? Doing the math, you get 180.08 grams per mole. That's molar mass. And I gave it the symbol M.M, molar mass. Okay, step 3, apply triangle 1. Convert grams to moles. Okay, moles is equal to mass divided by molar mass. Remember, that line is division. Let's apply it over here, and then we get this number of moles. Now notice how I've just reshaped this number to look like a power of 10, okay? Okay, let's move to step 4, apply triangle 2. Now I'm going to apply triangle 2 here at this stage where I have Avogadro's number. Notice the unit, number of molecules. I'm just going to add here my number. That's my symbol, that's my personal one. This is not in McDougal, it's just my personal preference. So number of molecules per mole, and this is the number of moles that you've got. Divide them by each other. Sorry, multiply by each other, and mole cancels with moles, and multiplying these two numbers, you get 33.121 times 10 to the 19 number of molecules.